Okay. Many a times to give a better explanation, sometimes you need to speak in local languages. Any case, as the title says, today's topic is what? Structures, classifications and common names. So, what we do today, we will basically we draw the structure, we talk about the structure, mean the when I say talk about the structure means structural features, okay. And then their importance, their occurrence, where do we find them. I think I will begin with anthocyanins. Anthocyanin will begin. Anthocyanin is nothing but the pigments of the flowers, seasonal flowers for example. See, most of the flowers color actually comes from these things, and then the structures. What are the structures? Structures basically say flavone. Flavone, any idea what is the flavone? Flavone, okay, kothay go? There is no nothing. Oh, I see that is not working. Oh, only this one would be working fine. Okay, so let us say begin with anthocyanin. You will find the reference of these anthocyanins everywhere, almost any standard textbook, natural products chemistry everywhere, and they would look like structurally. The way I draw here is a 6-membered ring, another 6-membered ring fused together, and then there would be an oxygen in the backbone, and then the structures obviously as usual, but what you see here is an oxonium ion, and then X minus, and then subsequent and then at some point I presume here on the top there should be an aromatic nucleus, and this nucleus could be on this oxygen side also, and let me quickly give you actually the correct structures. So, this is basically the pyrrhelium structure, and there are other kind of structures. So, it would look like again these, and then you have the structures here, the oxygen side there would be an aromatic nucleus. This is the basic structures. So, you have all possibilities, but this one, the one with the block within the block is the right structures, and then you have all kinds of the substitution patterns here, and mostly the methoxy and all methoxy, because these aromatic polyketides they will have this nucleus of this kind. Okay. So, that means this chromophore you can say actually are responsible for different kinds of the color. Normally the colors could be red and purple and occasionally blue. So, you have then all kinds of the colors, they are actually due to this kind of chromophores, and then there are other kinds of things. So, essentially what I am trying to say that the many dyes, organic dyes and the pigments are of heterocyclic nature. Okay. And then the other structures which we should know rather, we have already talked about the quinoline, isoquinoline, acridine, etc. Let us begin with one of the most smallest kind of structure. For example, all of us know this is a pyrrole. This is a name accepted all over the chemical literature. Then if you put a backbone, this is indole, all of you know, but then what is this molecule then? What is this molecule? And if you just complete this structure, since we know in our laboratory we work, this is basically important backbone, okay, carbazole. Then just writing structure is not enough, you have to remember in terms of the structural features. How do you remember? What are the features first should be remembered, that is important. So, you have all kinds, which one should be remembered first? Okay, I think I will go by him, but when we come to the nomenclature, it is a different thing. But when we talk about the structures and the features, yes, the heteroatoms. The heteroatoms should be first. Next is size, next is size, third is basically the fusions, the what kind of fusion is there. So, these are the thing. Okay. Then so, in this for example, when I say to carbazole it is a nitrogen heterocycle, then we say ring size. Ring size normally, if what is ring size? Okay, ring size. Okay, ring size I would say like this 6 5 6. It makes a sense, right? So, if you say so, that means I mean without writing you can simply say the carbazole is a nitrogen heterocycle, it is a 6 5 6 system. Well, more precisely you can write 6 5 and 6, that 5 membered ring is containing the nitrogen. Okay. So, likewise then if you let us say write one more structure and you have now something like this. So, that means you can generate structure by fusion, you can generate, that means what are the features? Features again size, number of heteroatoms, etc., the nature of the fusions and all kinds. So, like this one, the next one should be categorized as I mean one can write indolonaphthalene, right, or else one can write naphthoindole, right, one can write benzocarbazole. There are all kinds of things. We will come to this nomenclatures next class, but just to see that these varieties of the structures we ought to know. So, for convenience sake we can simply say these are all called benzocarbazole, but that is not enough though, but still as a common noun it is perfectly all right. Then you can just increase the structural diversity just by putting one more nitrogen somewhere else. For example, the one nitrogen, if the nitrogen is placed some para to this another nitrogen, this is categorized as carboline. So, it is a pretty famous kind of molecules, they occur in nature as well as natural products as well as synthetic materials. Likewise, carbazole could be of different kinds. Carbazole could be naturally occurring, could be also synthetic materials, and as we go on we will see carbazole also forms the monomer of the backbones, polymers, and occasionally they would be considered as optoelectronic materials, and many of the carbazoles also are semiconducting materials. So, that means they are of high utility. Which one? Carbazole? No, unsaturated. Carbazole is unsaturated, right? Or more, right? Okay, fine. Yes. So, and then there are molecules of these kinds. These are also these are the basic backbone. What you see here, there is a 6 membered and 5 membered ring system, 6 membered 5 membered ring system, and just hold on. Hello. Any case, this sort of compound is known as indoligidine, and there are plenty of organic molecules of this kind, but structurally you see it has a nitrogen heterocycle, it is a 6 membered and a 5 membered. It looks like analog of indole, but that is why it is known as indoligidine, and but it has a special feature. What is the special feature? That the point of fusion is carrying the nitrogen, and there are plenty of this thing. Then there are other quite famous kind of aromatic system like this one. This is. So, what is this? What should be the common name rather? What is the common name? The perihelium ions. So, likewise you have all kinds of these things, and then many of you probably I mean we can basically based on these let us say we can go on to the next one, probably the more popular one, that could be, I think many of you know this is here you have nitrogen, bicyclic nitrogen and nitrogen, and what is the basic skeleton? What is the name of this basic skeleton? Purine, right? Purine. So, it is a purine. So, that is the basic skeleton, that you have to remember, because such a common name and a very useful name. So, you have to remember them, and then if you let us say if you put carbonyl up here, and by convention we do not write, right. So, one line means it is a methyl group, we do not in structured writing we do not write these things CH and other things, only these hydrogen attached to heteroatoms should be indicated in the nomenclatures or in the structure writing. And then you have double bond and this thing, then you have a methyl group up here, methyl group and a methyl group up here. And what is the nickname of this molecule? It is a real life molecule, not really, we will come to that. Xanthine also will come to that. These are all very common names, you have to remember. I mean, nothing can be done, but this is caffeine. I think you did this work, right, in the lab, you isolated caffeine. So, it is a very common experiment, right? Abhishek did that. Huh?
So, we did that.
Right, it is a nice white powder, you college. So, it is a nice thing. That means, it is all heterocycle. That means, we begin our life, our day with heterocycle compounds when we drink tea. And then okay, so then let us see other important compound could be like say this one, once again 6 membered and 6 membered, and then when you write you can just quickly remember these things. It is 1-3 relationship on the if you go to the purine nucleus, this left hand one also is 1-3, this is also 1-3, and the basic skeleton up here, let us say then you have 2 more nitrogen. Okay. And what is the name? Close, right, pteridine, right. So, the basic nucleus is pteridine. Now, when I say pteridine, why is it so famous? Why should it be known to us? Because this nucleus occurs in many important pharmaceutical. One of them is folic acid. Many of you know, I guess, the folic acid, right. So, folic acid is known from your school life, right, but at this point you have to describe in terms of the structure. When I say what is a folic acid, you have to say something about the structure. Anybody knows what is folic acid? So, partly. So, that means you have to have 3 components. Let me write down, because it is a very useful one, because I will tell you little more about the structure, See, I mean, structure writing is very easy. Once you have identified the nucleus, then it has a methyl group, forget about the double bond, etc., all these things. Then like what Anindya says, that it has to have a ring, aromatic ring kind of things. So, this is para amino benzoic acid part. Okay. Then here little bit of interestingly, I mean, if you remember glutamic acid. What is glutamic acid? How do you remember glutamic acid? I would say glutamic acid is an amino acid which contains how many side chain carbon atom? Side chain carbon atom, because all amino acids will have the backbone carbon, one backbone amine, backbone carboxylic acid. So, rest is basically the side chain. So, how many side chain carbon are there? No, 3, including these things, these 3. Okay. So, carboxylic acid. So, that is how it is very easy to remember the structures once you just practice. Okay, I think I made a mistake. So, it is now it is 3. So, what you see here, this is glutamic acid, and this is what do you call? PABA. PABA means benzoic acid. GABA means gamma amino benzoic acid. So, likewise butyric acid, right, and then some double bond here, and now just basically just fill in the blanks. You have to remember that this has an amino group. So, this is folic acid. Folic acid, where do you find folic acid? It is a component, vitamin B, vitamin B complex. So, it is a part of it, and this is actually the origin of the discovery of chemotherapy. Many of you do not know the first antibiotic that was discovered in chemical literature was sulfonilamide. So, sulfonilamide actually the persons who discovered this, actually they found an analogy that if a cell survives on the use of folic acid, if you block the metabolism of this cell by putting a similar structure, and if you look at say benzene up here, this is amine, and instead of the carboxylic acid you put just this one, and it is a non-metabolite. That means the metabolism stops and cells do not get the food, and of course this dies. So, this was the principle that and now many of you know most of the sulfur drugs, at least some 50 different drugs are available in the market as antibiotics. Okay. And there are other kind of structures thing. Okay, by the way, just let me quickly give you an important information, though we will come back to that later, but the nomenclature wise, the numbering of the systems here, the purine and pteridine. All of us know these purine are present in this purine nucleus is present in adenine and guanidine, right. But what is the nomenclature? What is the numbering starts from? The numbering starts from is a peculiar numbering, though. But I mean that absolutely there is no science behind it. Numbering starts from here, the pyrimidine nucleus. On the left hand side is the pyrimidine nucleus, left top corner, or in this case 1, 2, 3, this is 4, 5, and the keto group is 6. Then what is the 7? Then again this is anti-clockwise and the roundwise now. Clockwise 7, 8, and 9. There is no science, just you have to remember. In case of pteridine, it is different. Pteridine is different. Pteridine is 1, this is 2, this is 3, 4, and mind it, these fusion points are not numbered 5, 6, 7, 8. Then the carbon. Then what are the numbers of these? Numbers no, it should not be 9 and 10. Actually, the top one should be taken as 4A, and this one next one would be taken as 8A. Okay, so these are the numbering you have to remember, and only like say, many of you know, like in steroid also you have the structures, they have a particular nomenclature. There is no systematic nomenclature, because those nomenclature the numbering systems have been retained and the old numbering systems. Okay. Let me so you know now, then let us say, let me give you one more biologically important molecule. For example, all of you know by now know, I do not have to say, but the common names have to be known, because for important communications you have to see here. For example, what is the backbone? No, beta lactam only the 4 membered ring part. Then 5 membered ring with a sulfur, what is the name? So, these are the thing, thiophene system, but together it has a nickname. These are things you have to remember, that is all. Like similarly like say this one, now you have a 6 membered cyclic compound. So, it has again a nickname, the name is called cepham. So, what is cepham? It is a bicyclic compound with containing a beta lactam series and this. Okay. And then why are they so famous? That also you have to remember. Cephalosporin. When you say cephalosporin, it is heard by everybody, but what is the basic structure? Now we know. The basic structure is this. Again, you can just without thinking much, you can write that, okay, 4 membered and a 6 membered. What else? What are the structural features? The structural features here you have cis hydrogen, that you have to remember, cis hydrogen, and those who have studied chemistry of penicillins, they would know this particular position is occupied by one heteroatom, nitrogen. So, penicillin G was one of the earliest antibiotic, and penicillin G must have an amino group up here, and then in this case the one I am writing here again this is amide, and you have this 1, 2, 3, 4 maybe I do not know this is aspartic acid something, and then you have a carboxylic acid up here, and then this is these double bonds, and these are the typical carboxylic acids of the nucleus. This is one of these actually this is cephalosporin, cephalosporin PO, PORIN C, cephalosporin C. It is an antibiotic. You do not have to remember all these structures, but you have to have idea about the basic structures. Okay. So, there are other molecules, I think there are plenty of different kinds of molecules. Let us say let me see I mean we can think about, for example, this is a molecule often we talk about. Again what you will find this is NH and say 5 member kind of thing, and it is a purine nucleus, and then CON and then NH, and this is again a purine nucleus, but all of the carbons are in the form of keto groups. So, and it has again a name, it has a name very famous among the non-chemist. What is it? Xanthine. No, right, uric acid. What is it famous for? Gout. So, any elderly people and most of the elderly people will know what uric acid is. It is nothing but it is this one. Okay. And there are similarly there are other keto compounds. For example, this is quite well known. It is a 6 member again. 6 member again, which is 3 nitrogen. It is highly symmetrical here, and which is having OH, and as you can see this is in equilibrium with again a keto group, and the keto. So, you have what you can see, you have NH, and this is NH, and then you have NH, and you have the carbonyl. Okay. So, there is an equilibrium, and but what is the name? This is a very useful compound. This is a very useful compound, and especially in biology. Pretty close. Actually, it is known as cyanuric acid. Cyanuric acid. Okay, that means the name implies that the keto form tautomerizes to the hydroxy form. Okay, so it's like it's a trihydroxy kind of thing. That means a phenol kind of things, very acidic. In presence of POCl3, you can guess what is the product. The product would be trichloro derivative. So, trichloro derivative, that means nitrogen and here nitrogen, and this you have trichloro derivatives if you have excess amount of POCl3 basically, and that means it is an acid derivative. So, it is cyanuric chloride. So, just like and you can use cyanuric acid chloride for converting carboxylic acid into the corresponding acid chloride. Okay. So, it is a chemical reagent, and many a times the cyanuric acid chloride also can be used for Beckmann rearrangement and all Beckmann rearrangement. Then there are many uses of the cyanuric acid chlorides, and then let us say okay, one more important class of molecules that I think I will write this probably would be knowing this. This is a molecule again. What you see here, the way I write is a 2 benzene nucleus, that means biphenyl system. Then you have a 6 membered ring with an oxygen up here, and so then dimethyl group, you have a CH3 group up here, then you have OH, and in here you have C5H11 aliphatic side chain. Anybody is familiar with this structure? This structure is cannabiol. Anybody knows? It is a active component of hashish, marijuana. So, marijuana, you can, so that means if you take this, actually this one is inactive. So, the active form actually is partially hydrogenated. That means, this ring parts remains as it is, then you have a phenolic OH group, and so you can have then, and this is partially hydrogenated here, then you have hydrogen up here and then alpha hydrogen, and this is known as tetrahydrocannabidiol. Of course, I mean tetrahydrocannabidiol, this is the more active one.
So, what is the use? What is the
Application. Application means, okay, you have to smoke, just like a bidi. If you smoke, you will be in a different world. So, ganja. So, no, mind it, but this I can tell you. No, it is interesting, it is very interesting, but at the same time you have to appreciate the activity. That means, we every day we swallow or we eat or we take all different kinds of chemicals, different kinds of food, but they have typical action, but only a small amount of this will have a separate action on the human body, physiological actions, hallucinations, hallucinogenesis, I cannot pronounce, okay, but okay, no, not hallucination, hallucinogen, something, hallucination, right? How do, okay, any case, hallucination, right, something like that. Okay, basically we can see, I mean, daydream. If you want to see daydream, you just take one, and then that's not a problem. I mean, I can tell you, I mean, if not recorded, then I can tell that this is once I took, but that's by mistake though. I mean, someone suggested me to take, any case, but no, but what is important, that such a simple small molecule as aromatic, nothing, but it has so profound effect on the physiological actions. And even today, I know one of my friends is still working on the cannabidiol, simply because if you can mend the bioactivity, means reduce the bioactivity, then that could be useful for the humankind, that is all. So, people are working on it, and they basically all these molecules are taken together, considered CNS agent, means central nervous system agent. So, that is the nicest way of combating different diseases. If you can monitor here, you can mentor here, then I mean, the rest of the things are okay. Okay, and so this is a very useful one. Then there are other molecules like, okay, since this afternoon, okay, Tanmay was telling xanthine. Xanthine is nothing but you have a molecule of this kind. This is called xanthine. This is the xanthine. This is the xanthine nucleus. This is the xanthine nucleus. So, and
those two hydrogens are anti
either trans, right, trans to each other. So, then other kinds of molecules many of you know, but for simplicity's sake, just for reminding you that one can also see this is a pretty famous molecule, right. So, but it should be considered as a heterocycle. On the right, this one is nothing but saccharin, right. So, saccharin, and there are other saccharin, there are other, I mean, there are plenty of different kinds of molecule, but I will write one more on which once upon a time we worked. Let us say this one, what you will see, this is again a oxygen heterocycle. So, it is a 5 and 6 and a 6 membered ring, right, and so you have two independent heterocycle, furan and a lactone, but there are all kinds of names though. For example, many of you know that a benzene ring and a lactone ring together is known as coumarin. So, coumarin is a very famous molecule, right, especially those who are working in the physical chemistry. What is it famous for? Famous coumarin, most of the coumarin derivatives, either Nilmani Sarkar or Mintu, whoever work, they work on coumarin, they are fluorescent, they are fluorescent molecules. For us, and the fluorocoumarins actually are pharmaceuticals, and there is a molecule called 8-MOP, I guess, 8-methoxy. Oh, okay, no, but one of the, this is basically a nucleus of a very famous molecule called psoralen. Psoralen is again a medicine used for the treatment of psoriasis. Psoriasis, what is psoriasis? Again a skin disease. Okay, skin disease, I mean sort of what do I say, a disease where you can have lot of itching and other things. Scaling is not really I have no idea, but it's very painful, that much no. I remember I have seen one patient in undergoing the treatment for psoriasis. She was put in the hospital, and it's a big room, and she was totally exposed to UV light. So, UV light, the medicine was applied on her body, and then UV light was given on that. Okay. And these are all called photodynamic drugs. So, when you are exposing this drug to the UV, it undergoes 2+2 cycloaddition with thymidine ring system. Thymidine has a double bond, so it forms 4-membered ring system. So, this is one of these. Then there are plenty of other. Okay, many of you know, I guess, the structure of methylene blue. What is the structure of methylene blue? Structure of methylene blue must be known to all of you. No idea? Methylene blue, okay. So, we should know that is a medicine, not say that is a drug, no, that is a dye, it is a tricyclic, and we will have a sulfur on the middle ring and the nitrogen on the middle ring. Okay. And then of course, rest of the things are quite simple, that you have rings, and what else? Any idea? Leucoform. Leucoform means there is in drug chemistry there is called leucoform. We call often leucoform. What is it? What does it mean? It is a reduced form. If you oxidize, of course, it gets oxidized, and para to the nitrogen you will have N dimethyl group. Okay. And so, likewise, there are other things like biotins. Many of you know biotins also is biotin and thing, and there are other small molecules that you all ought to know. This is a system called aziridine. If you put a double bond, it is known as azirine, right? Azirine. Similarly, you have molecules of this kind, that this is known as azitidine. So, likewise, and then there are other things like, for example, many of you are familiar with this molecule. For example, what is this molecule? Dihydropyran. To be more precise, it is known as 3,4-dihydro. No, actually there is a form called 2-pyran, 2H pyran. For example, actually the pyran nucleus is something like this. This is called pyran nucleus, and then we will come back to these sort of things, like we write hydrogen. Hydrogen, actually this is called indicated hydrogen. You have to indicate the number of the hydrogens or the place of the hydrogen by saying hydrogen. If a hydrogen is present in excess over the what? Over the sp2 carbon atoms. Suppose if you had sp2 carbon atom here, you would have expected only single hydrogen. Now you have additional hydrogen. So, that is the reason this. So, this is actually 4H pyran. This is actually 4H pyran. So, that means this comes from actually here. This is, let us say, this, and this is what should be the name of this one? This is actually 2H pyran. So, that means in this case 2H pyran, and that means this is 1, this is 2, this is 3, this is 4. So, that means this portion is known as the 2H pyran, and then you have 3,4-dihydro, or you can say 1, 2, 3, 4. So, that means why? Because hydrogen is considered to be a substituent here, that is why it is given the name 2H. Okay. And Then other I just like to just the last minute maybe we will just one more structure that should be known. Once again we have somehow come across this molecule here. It's one 7 member. There are very few 8 member 9 member heterocycle molecules. Okay. I mean truly speaking, then this is a if you have nitrogen. So, this is basically we known as pen. Pen actually stands for the 7 member ring. Then now if you put Pen is a basically nitrogen containing 7 member ring. So, similarly if you have a sulfur in the presence of thiopene, okay, and if you have double bonds here azipines. So, all these names we will talk about more on in next class, and then let us say I think I have talked about most of the important ones. There are other heterocyclic reagents also. There are plenty of organic heterocyclic molecules which are useful as natural products, which are useful as medicines, which are as agricultural chemicals, polymeric monomers. Then there are chemicals like which are used as an oxidizing agent or reducing agents. One of them I think many of you probably remember. We talked about a reagent called Davis reagent. What is Davis reagent? Okay. Davis reagent is basically an oxidizing agent. So, it must have an oxygen and it is in heterocycle. In a heterocycle, smallest heterocycle and with smallest heterocycle and it contains 2 heteroatom oxygen and nitrogen. It is a pretty stable one, but it can be used for oxidation. Hello, হ্যাঁ বলো কোথায় এই রে আচ্ছা আচ্ছা আমি তো আবার সেই আমার রাবারে একটা Okay, I think we will stop here, right. So, we have actually taken care of most of the important nucleus. So, 5 membered, 6 membered, occasionally 7 membered, and there and most of them are many times fused, that is all. And there are other types of molecules also known as cyclams. Inorganic chemists would know what is a cyclam. Cyclam is it's a macrocycle. It's a macrocycle 4, 8, 9, 10, 11, 12 membered macrocycle containing 4 nitrogen atoms, symmetrical molecule. So, you can understand what it is. Okay, there is a nice ligand actually for metal complexes, for formation of the metal complex. Then there is a I mean in my note whatever we have called methotrexate. What is that? Anti-cancer agent. But that is not enough. That has to be known to you because this is an advanced level course, but what is then next thing? The structure. Okay. So, we will ask this question next time. Okay. And read little bit about these and then let us say for example, one more molecule I have in my note is called riboflavin. What is riboflavin? When I say riboflavin, then you have to describe to me okay, what is it? No, that is not enough. That is what I am trying to say. You have to tell us something about the structure. What is the possible structure? If okay, that means you can give better idea if you tell us about this structure. It is a basically pteridine nucleus, benzopteridine. So, I think now you can make out what it is, right? No, I said benzopteridine. So, that means a benzene is fused to the pteridine systems, and what is pteridine systems? It is a bicyclic bicyclic nitrogen containing compound. Okay, 1,4,4 and 1,3 nitrogen nucleus. Okay. So, in any case, next time what? Next time we will have again a little bit of thing which should be remembered. There is no science on it. That is nomenclature. How to name an organic heterocyclic compound. For example, the one I am talking about here. So, what should be the name? Like say this one. So, in the next class we will talk about the oxygen. So, fine. So, in the next class we will be talking about, so what should be the name? There are two things we can say, right? Is oxidane, azaoxidane you can say, oxidane, or you can say oxazidine. Which one would you say? Absolutely, there is no science, as I said. Whatever I said you have to remember, means whatever IVPs said I have remembered, and I will tell you, okay, you also remember that. Okay, best way to, okay, next class we will just try to remember this one. When you write this, it is a tick mark, right? See, anti-tick mark, you remember, then I will tell you what it is. This is a very important clue in naming an heterocyclic compound, especially when you have two different heteroatoms. In this case, you have oxygen and nitrogen. So, fine. So, what is that? So, today's conclusion, anti-tick for tomorrow. Okay. So, I think we conclude here.